And we're live, I think. All right. Good afternoon, everyone. Welcome to a revision lecture. One of our several great week 6 activities that has been set up by the COMP1511 team. Mainly not by me. Big thanks to the various people who have been doing things this week. So let me be clear, this is an optional revision lecture. We don't introduce any new content in this. We're going over old concepts and trying to give you some help with that. So Tom number 1. We have 2 Toms. Oh, I should do some introductions. So we have Tom number 1, who, course admin, who is actually not going to do much with this lecture, though he's been instrumental in setting it up. We have Alvin, say hi Alvin, who is one of our tutors, who's going to be giving. Well, I thought it'd be best to have the tutors because they spend so much time helping students. I thought that they actually have better insight into how to help you with revision than I would. So we've got Alvin, and we've got Tom number 2, or Tom Killingback, who will do most of the talking today. But first, Tom number 1, questions. If students have questions they'd like covered, they should post them in the chat for the lecture.
Yep, that's the plan. Just post in the YouTube chat if you've got questions. We've got some content which we've already prepared, which Alvin and Tom Killingback have kindly gotten ready for us already. But if you've got particular things you want us to cover, just post them in chat and we'll do our best to do so.
All right. Okay. I first should say, you've probably seen the fairly dismal news this morning about coronavirus in Sydney, and it seems the likelihood that we'll be leaving the lockdown in 10 days' time is looking unlikely. So if you're feeling a little depressed and sad, you're far from alone in the city of Sydney, I think. We're all feeling pretty miserable about this. I should say COMP1511 is particularly well placed to cope with lockdown. So we can shepherd you through your university studies in this course, probably better than just about any other course in the university. So I guess that's one plus for all of this. The other thing I'd say is please keep yourself safe. And UNSW generally, not just this course, is looking for students who are going to become leaders in Australia or elsewhere in future. So not only keep yourself safe, but try and, in your social circle or whatever, make sure everyone else knows what they're doing and are staying safe and so on. All right, let's move to course content. So Alvin or Tom Killingback, who wants to go first?
Can I actually jump in before either of them do that?
Please.
Just one other note on the lockdown bit of it. If as you know, it's understandable, it's quite distressing. Some people might be in certain situations. If you're struggling with COMP1511, reach out to us, email CS1511. We're happy to have a conversation with you about if there's things we can do to help you, especially given the current circumstances. If you're having problems that are bigger than 1511, so things to do with insecure housing or psychological issues, anything at all, the university has a range of support services. I'm not going to list all of them here, but again, you could get in touch with CS1511 if you wanted to get more referrals to those. There's also great documentation online. The best place to start would be the Student Support and Success Advisors. You can usually Google by just looking for UNSW Student Advisors. They'll be able to give you a bunch of help there too. So I think we'll say this again next Tuesday at the lecture.
Tuesday, yeah.
Yeah, but just so it's noted.
I would say even the nucleus, people in the nucleus know all the support services the university offers and are great at directing people to them. And the other thing I'd say, there's the university counselling service deal with a wide variety of students having a wide variety of issues and are superb. All right. If you've got any other general questions, you can put them in the chat. But in Tuesday's lecture, we'll go back into this stuff. So I think we said Alvin was going first. All right. So Alvin, if you want to start talking and share your screen about what topic you'd like to cover.
Yep. Hi everyone. So my name is Alvin, and I am sort of going to be talking about arrays. So if you guys could chuck in your questions on arrays, that'd be wonderful. So I'll sort of wait for about 20 seconds to see that. But if not, I could sort of give a journal thing or two to watch out, or like things like that. So I'm just gonna wait in the chat for a bit.
Alvin, just so you know, the chat will be quite behind because we are streaming on YouTube. So just so people know, if you send us a message, we might take 15 or 20 seconds to notice it. It's just because YouTube is slow.
That's fair. Yep. Cool. If there are no questions, I'm just gonna give a brief overview of what arrays are, and so that we could jump on the 2D arrays as well before doing 2 more questions, I'd say. So let me share my screen. Cool. I hope everyone could see it. At least everyone in this chat would. So yeah, when we talk about arrays, I guess we could start with, is this stream meant to be unlisted? So I believe every stream is unlisted until they are done. And the reason for that was, I believe a few terms ago, it was live, and then someone else outside from UNSW tries to access our stream, and the chat was just not great. So after that, we have unlisted lectures until they're done. But it should be accessible in the course website still. Yeah, so getting back to arrays, I believe, arrays are a collection of variables, right? So let's say, you start out with int, maybe, num0 equals to 1, and then, if this is just, a bunch of variables, integer variables, for instance, and then, if you are to collect this, yes, with 3 numbers, it made sense. But what if you have like 100 variables? There's no way that you're gonna write int num something equals to another number, for instance. And hence, we have this collection of array. We have collection of variables thing that's called an array. So when you were to define an array, you would define it with something like this. So let's say, we have in nums, and then this would be a number, which corresponds to the size. So I guess, if we were to have a main function here to just make things clear, so we have in main void, right, and then we just have return 0 over here. So if we were to define the array inside the main function, for instance, oh no, I lost it. And that would then mean int array, and then this would be the size. So, for good style, I would define the size outside of the main function. So let's say 7. So here we would say size 7. And then if you know the values that you're gonna put, then you can just write it down. So if I know the first 3 numbers, then I could just write it down like that. But one thing to note though, if you define any of the numbers, then everything else then initialize as 0. So that's a good note to think about. So if you were to just visualize this, right? So we have defined an array of size 7. So, when I like to think about arrays, I like to think of everything inside in a particular box per se. So 1, 2, 3, 4, 5, 6, and 7. But if we define it as 1, 2, 3, as this thing looks, then it would be 1, 2, 3 over here, and then the rest would then be 0, right? So this is sort of like the array that we just created, and I guess when we are planning to change something inside the array, right? So when we want to access an element inside of the array, then what we would do is then see which element that we want to change. So let's say we want to change this particular 0 here to be 5, right? So this isn't like the initial value that we have. So we're just changing this somewhere in the middle. And then here we can see how, this is the 0th element because arrays start from 0. Why can't I use my pencil? Oh no. All right. This is not great. Oh no. All right. Let me refresh this. So whiteboard, please work. Technical difficulties. Sorry. Hopefully should be all good now. Got it. Yeah. So let's say we want to change that from 0 to 5, right? And then we know that arrays, we start counting arrays from array 0. So in that case, this is array 0, array 1, array 2, array 3, and then array 4. So what we would do here would be to say array 4, because that's the 4th index, equals 5. So that's sort of like just a brief 101 on arrays. So are there any questions so far before we sort of move on to 2D arrays? Again, there'll be lag, so I'm just going to continue for now. But when we sort of go towards a 2D array, then it becomes more complex. But try to think of it as an array of arrays, right? So let's say we have this particular array. So let's say this in itself is a part of a bigger array. So I kind of stole this idea from the other Tom who's going to talk today. But I like to imagine 2D arrays as a collection of arrays themselves. And hence, you'd have something like this, maybe. Then maybe we would have, I don't know, maybe currently it could just be all 0, 0, 0s. And then that in itself could then be 2, 4, 0, 0, 0s, 5, 6, 7. So it's an array of arrays. So in here, we can see how this array has a size of 3 by 7. And hence, when you were to define it, so here we can change this defined value to then be row size to be 7. Sorry, column size to be 7. So columns are how many numbers in a particular line, so particular row. So it's the horizontal scope. So col size is then 7, and then hash define row size. Then we know that this is an array of 3 arrays. So that's why the row size is 3. So when we were to define this particular array, so actually, sorry to keep going back and forward, but let me just sort of define this everything to be 0 for now. But it would then be, this is again in our main function. It would then be int array, but we will have row size, col size, and since we declare everything to be 0, we can simply do this. Technically, we're defining the very first element, which is this particular thing, to be 0, but then everything else would then be initialized as 0. And as I've said before, because an array, a 2D array is an array of arrays, right? So if we want to access this whole array, this will then be array 0. So array 0 corresponds to the whole first row of the array, and then array 1 would then be that, and array 2 would then be that. But if you want a particular element, for instance, so if you say if you want to change this again to be 5, right? Then we need to access where in the first row it is, right? So you know that this is in the first row, so it's in array 0, but it's the third element in array 0. And hence we can sort of simply do, it's the third element in array in the 0th array, so it then becomes array 03 equals 5. So this is sort of like the overview of 1D and 2D arrays. And now I may actually touch on a different problem if there are no questions. I'm not sure how to zoom out.
I think you want to scroll out.
Yeah. Yeah, probably. Sorry. Right. So I'm just gonna stop sharing my screen for now and change into VLab. And again, please type in your questions into the chat. So now, I guess on this particular problem, we know what currently we have an array of 1 dimension, and that I defined as 1, 2, 3, which meant that it's initialized. The first 3 numbers are initialized to be 1, 2, 3, and the rest becomes 0. And then there's this array of size 7 by 7. So this array 2 here is a 2D array, but I have defined the first 3 numbers of every of the first 3 rows. So again, I don't need to complete this, I believe. So let's see if I would need to actually write 0 here. So if I were to compile this, yes, you can see how, sorry, I may need to put a new line over here, because then you can see how this is the first 1-dimensional array, and then this is the second dimension, the 2D array that I printed. So as you can see, in terms of defining, yes, this looks pretty confusing because we have a 7 by 7 array, but I'm defining like the first 3 by 3 array. But you know, if we were to put this as 0 and rerun this again, it would then be just an array of zeros. So I would argue actually the previous one may not be the best style, because it makes you wonder whether the array is 7 by 7 or if it's a 3 by 3. So it needs the extra overhead, in my opinion. Feel free to chime in, Tom and the Toms and Andrew.
Alvin, I was going to ask, do we need to initialize our 2D array to 0? Or if I don't do equals squiggly bracket 0, what happens to the array?
So do you think that, so just like this, do you think, Tom?
Yep. Do I need to equal 0?
That's a really good question. And we can sort of try it out and see what happens, you know, try and break things. You can see that we have found an uninitialized variable error. And as you can see, when we try to print the array, it is saying that, hey, what you're trying to print here, which is an integer, is uninitialized. And the reason is if we just write something like this, instead of initializing everything as 0, you're telling C or the compiler that every number inside is still uninitialized, and you can't print an uninitialized number. And hence, even you at least, I guess, even if you need to erase, or I'd rather sort of define everything as 0, just so that at least here you can see how the array would then be 0. Although there are some instances, I guess, if 0 itself is something of a variable that you want to record, then that could be an issue. But for the most part, initializing arrays would be a really good way to start. But the problem before, as I have told you, is because when we try to print an element inside the particular array, it is then uninitialized.
The other thing I want to add on to that, if that's right, Alvin.
Yeah, of course.
Is that this error message you can see here says the error message is with the printf. And I often see a lot of students get confused because they're saying, what's wrong with my printf? It looks fine. I've got my double quotes. I've got my comma, my variable, and my semicolon. Like my printf looks fine. I think printf is broken. But it's important to read all the details around it, because although printf is fine, it's saying that the variable it's trying to access on that line, that the variable is the one that has the issue. So in a much bigger program, such as your assignment 1, or as well with your assignment 2 as well, when you have C files that are hundreds of lines long, forgetting to initialize something on line 13 can cause you an issue in another file on line 350. So it's a real skill to be able to read compiler errors and runtime errors and error messages and things like that. But this is a good example of something that looks like the error is with printf, but it's actually with the variable itself.
Yep, a good note as well is to see which line that they're referring to. So
yep.
Here you can see how this is line 50, and hence, you can scroll down and see what line 50 is, and sort of like try to understand what the error message is. And just sort of like, as a credit, like DCC itself is actually designed and made by Andrew Taylor. So I believe, I'm not sure if the standard GCC would give me this error. So it is pretty good to sort of start with, a compiler that's very accessible.
Yeah.
But yeah, moving on from that, if there are no questions, then I have made some questions myself. So let's say, in a particular 2D array. So let's say if how do we want to find the sum of all the numbers in a particular row or in a particular column? So let me just, for clarity, let me just sort of define what the first two rows or the first row is, I'd say. So 7. So I'm just going to define the first row here. And I think that's it, because I'm just defining the first row and not everything else. So we can try to see if this works, right? And now we have, the first 1D array, which I feel we could delete, and then the second 2D arrays here. And here we want to find the sum of all the numbers in a particular row. So what that means is that, if there's this function called int get row sum that essentially tries to add all the numbers that happen in a particular row. So I believe in rows and calls here, as you may have noticed, is the size of a row and the size of the column. And hence, when we print to the array of a similar structure here, you can see how we did use size and size to indicate that the array 2 is of size, of row of size, and column of size. And then if we were to get So here, we would get all the sum of integers at a particular row. And to make it better, it returns all the sum of all integers at a particular row. So here, if we were to use this function, for instance, right? So let's say we use this on the 0 row. So then we would use it something like this. Hence, again, because this returns an integer, you can print it off directly, but you can also catch it by saying sum row 0 equals get row num, and at that point, you can print sum of row 0 is %d, and then it becomes sum row 0. And here, the key thing here is that we want to find the sum of the whole row here, right? But how do we approach this problem? If we want to find the sum of all the numbers in row num, technically we kind of want to print array row num 0, and then we want to add with row num 1, and all the way to array row num calls -1 here, which is key because we start from 0, and then if the array in itself has a column length of calls, then the highest index would then be calls -1. So here we kind of want to find this sum, and how can we then approach this problem? As you can see, there are a lot of similarities here. You see how all the row num is the same because we're adding all the numbers in a particular row num. And then you can see how that goes from 0 to calls -1. So then this kind of looks like a while loop that goes from 0 to calls -1. So if we have something like in I equals to 0, and then while I is lesser than calls, you can see how I here kind of goes from 0 to calls -1, because this is the starting element, this is the incrementer, and then this the while loop itself would stops when I is then bigger or equal to calls, right? Because it's the opposite of what the condition is, and hence I would have then traveled from all 0 to calls -1, and hence, if we were to print we don't want to print, we want to find the sum, so we would need to have sum equals 0, and then we would add the number into sum, which is then array row num, which stays the same, and then I, right? Because this way, then the very first instance would then add array row num 0, and then the second instance of the while loop would then add this, so on and so forth until it finishes at that point. And here we would then return sum. So let's see if this works, right? Sum of row 0 is 28, and I believe if you add all that up, it will be 28. Let's see if row 1 would be 0, for instance, because everything would then be 0. Should copy all the 2 rows here. So it would get the sum of the first row. So are there any questions while I try to run this, and possibly I could see in the chat? But so we have found the way to add all the numbers in a particular row. So that is the 0 row, and then that's the first row. So the second problem that we also have currently is how to find the column sum. So if we currently add all the column, we have done adding all the numbers in a particular row, and now we have to do it in terms of the column. So I can see how this would be very similar, right? So I would try to approach all problems using trying to see what it ends up with. So instead of like trying to code it up directly, I'd say how, you know, when we want to add the rows, what particular numbers are we actually going to add? So this is sort of similar with your assignment as well, maybe stage 1 or 2, where you may have to do that. So outline what are the numbers that needs to be printed, or, you know, if you want to find how many mines, for instance, and that could be an easier workflow, I'd say. And so if for the column sum, right, so we are going to copy that when we try to implement this yourself. So again, we would then look out what are we going to print, you know. So if we were to find the sum of, you know, a particular column, so let's say it's this column, right? So we would print we would add these numbers up, keep mixing, adding with printing. But we would then, you know, so what are these? So let's say column num is 2, because it's the second column here, even though this is 3 because it starts from 1. You know how we want to find the 0th row of column num, and then the first row of column num, all the way to then rows column num. Maybe rows minus 1. Again, because this starts from 0 and ends at rows minus 1. We would then have a very similar while loop, right? Because we would then need to add all the sum up. But then instead of traversing into all the columns, now we would traverse along the rows, because we would add all the numbers that are in the same column in each row. And hence, it would then be sum plus equals array I, because then again, you know, I goes from 0 to rows minus 1. And then we're adding all the numbers in that particular column number. And then now we can just return sum. So it looks like this code is very, very, very similar, but you can see how the I is on the second, I guess, argument or square brackets, which indicates that it's traversing through the column, and here it's traversing through the rows. So we can try to test this out, but again, are there any questions? Feel free to put them on the chat. So let's say we want to find the column 0's sum. I'll probably change the array a bit to see if it makes sense. Probably 4 this time. So we want to find And maybe if both Toms and Andrew have something to add, feel free to add it now as well.
It's looking pretty good.
Thank you.
This is, very similar to a part of the assignment.
Yeah, so big hint.
Yep.
If you haven't started the assignment, which I feel like you should, because it'll be very worrying if you haven't. But
If you haven't started the assignment, now would be an excellent time to get in touch with your
It's never-
tutor and ask their advice.
it's never too late.
It is never too late. There's
But-
an ancient proverb: the best time to plant a tree is 20 years ago. The second best time to plant a tree is now. So, but yes, get in touch with your tutor if that's the case.
So here I'm modifying the array now to have an array of size 7 by 7. So 1, 2, 3, 4, 5, 6. And you can see how the arrays are just 1, 2, 3, 4, 5, 6, 7, all 7 rows. It was just, testing column this way is kind of boring. So if we were to run this function again, this file again, you can see how now the 2D arrays are all that, which is literally the same thing with that. And you can see how the sum of row 0 is 28 because the sum of all these numbers are 28. Again, same thing for row 1, right? Because it's all the same number. But column 2 are all 7 3s, which is then 21. And all column 4 here would then be 7 5s, would then that would then be 35. So are there any questions on this particular problem? I believe I could send this code to Andrew, which could make this a code in the course website. But then again, this code also, feel free to just look at this currently and watch the recordings. But if there are no questions, then I could stop sharing my screen and give my screen to Tom.
Yeah. Cool. All right. So if there's any questions on arrays or anything like that, feel free to still ask while I'm talking. And Alvin, please feel free to jump in while I'm talking as well. I'm going to talk a little bit about functions because I think functions are super, super helpful. What am I doing? I'm sharing my screen here. Let's share a window. Let's go with VLab here. So I've got a nice little program here, and I've got it to print out my age, right? So I've got a hash define here that says years 20 years old, and it just counts from age 0 up to 19, right? Let's make this a little bit more applicable. Let's say I'm going from age 1 up to and inclusive of my current age, right? So let's compile the program. Let's have a little look. Test.c. Okay, good. I can write that. We'll get that to compile, and you can see no problem, right? We know how to do our while loops. It counts from 1 up to including 20. But what if I wanted this to print out the age of multiple people, right? So let's say I wanted, I wanted this to count up from Tom's age. I wanted it to count up to Alvin's age. I wanted to count up to my dog's age. So one thing I could do is I could take this code and I could say, well, it's going to count from my start, my current age. That's what it is probably should be called, my current age. Ooh. Let's make sure I can copy things correctly here. We could count up my current age like this, and then I could come through here. I could say, well, Tom's age is counting up to 20, and then if I wanted to count up to Alvin's age, I could come here and I could say, I want to count up. I want to reset my current age back to 1, and I want to reset up to Alvin's age of 21, and then I want to print my dog's age. I'm going to do exactly the same thing, and I'm going to say she's 4 years old. Now, when we're programming and we're writing code like this, it's important to sort of try to identify any kind of pattern you can see. And there's a nice pattern here because it's the same kind of format. So we can see that where every time we want to print out someone's age, we're always going to print, we're always got a while loop. It always starts at 20. It always goes up to and inclusive of that age. And we're always incrementing our age. So this is quite a nice little pattern. Now, if this was everything our program did, it's not super difficult to copy and paste the same bit of code. But we're programmers, we like to be a little bit lazy, and we want to try to make this a little bit more efficient in terms of the number of lines. Let's just compile this program to make sure it works, because it's likely I've made a mistake. Well, for the first time ever, I haven't. We're going to recompile our code here. Yep, and now we're going to run it. And there we go. So you can see it's counting my age, 1 through 20, and then it's going to do Alvin's age, 1 through 21, and then it's going to do my dog's age, 1 through 4. But we've had to write, what is this, 30 lines of code. This is a good example of where we could use a function. And I'm just going to swap my screen share now to a whiteboard. There we go. I'll wait for that to come through. So the way I like to think about functions is sort of like a black box of code that we can reuse, right? A good example of this is a sum function, right? So if we take our function here, let's represent our function as a black box, a reusable bit of code. Our sum function, well, it has a name, right? So all our functions have a name. So this is, instead of calling it sum, let's call it my addition. And our black box takes in some inputs. It's going to take in some inputs here. So this is going to be our input 1. And it's going to have another input here, which is our input 2. Right, and these are our two numbers which we want to add up. And then it's also got an output. Some functions don't have an output, right? But for our specific addition function, we know it takes in 2 integers, and we know it's going to return a single sum. And what's useful about this is that it has, for any non-specific inputs, we can apply the same operation to it and give it some output. So, this is helpful for addition, but addition is not such a big problem because we can do it with one line. But it may be more applicable to our, age printing out function. In terms of how we write our functions in C, I find it, it's kind of counterintuitive the first time you come to it, because you kind of write it in reverse. You kind of write what is the output, what's its name, and what's its inputs. Whereas it's usually a little bit more clear to read this as what are my inputs, what's it doing to them, and then what's it outputting. But that's okay. So let's convert this to how we would write a function prototype in C. I know Andrew's mentioned before that C is a typed language, so we have to tell the compiler what type of inputs we want. So we're going to say we're just going to do integer addition here. So we're going to say this is an int input 1, int input 2, and we're going to say, for the sake of it, we're going to have an integer output. And then this is our name, my addition. So how do we write a function prototype this? Well, we have to write its name. So our name is my addition, right? That's our name. I'll just do that in a nice blue color. We have to tell it what inputs we want to use. And the thing about the inputs with function calls is that the arguments are ordered. So if we say we want to have our first int input 1 here, and then our second input, second int input 2 here, then whatever number we pass into the first argument here is always going to be input 1. The other thing we have to tell the compiler is what type of variable we're returning, and we are returning an integer for this function. Okay, so this is like the general form of a function, but if we want to do our age printing out function, it's going to be a little bit different. So let's look at what that might look like. And when I'm writing my functions, anytime I'm doing coding, I like to think about my use case first. I like to not think about how I'm going to do it, because that's kind of like a later me problem. But right now I have to think about how I'm going to use my function. So if we think about my print age function, what do we want to do? Well, we want to print our age. So we're going to call it something descriptive along those lines. So let's call it our print age function. What does it need to take in? Well, it's got to need to take in, the age we're counting up to. That's the only thing that's kind of different between. It's the only thing that's kind of different between different instances, different times you call the function, is the age it's counting up to. So let's give it an integer age again, just to make things easier. And let's say int age, right? And what's our print age function going to return? Well, remember I was talking earlier about functions that can return nothing. Because we're just printing out to the screen, that's not actually returning anything. That's not returning any kind of variable back to the place that called the function. So although we are outputting something from our function in the sense that we are printing to the screen, we're not actually returning anything. Therefore, this is going to be a void function. So let's take this function prototype and let's implement that in our code now. So I'm just going to switch. Screen sharing again. Here we are. All right, so we're going to take our prototype, which we just wrote, and we said, well, it's not going to return anything because it's printing. What's it called? It's called print age. And what does it take in? It takes in the maximum age. And we put our prototype right up the top here, just to keep our code nice and clean. And then we put our function definition right down the bottom here with some nice brackets, just like this. So we know what we want to roughly do this section of code, because we can see that's the pattern here. This block of code here is the pattern. So let's copy this out. Let's copy that code. We'll put it in here. And we're going to say, that's not formatted that very nicely. There we go. We want to count up from 1. So we know we're starting at something, up to something. And there's no point having a constant down here. There's no point having a magic number down here, because we're able to, that doesn't make our function very portable. It means we could only call it once and it would always call up to 20, which kind of defeats the purpose of having our function. So instead of counting up to the constant 20, we're going to say, let's count up to the constant, to the variable passed in called age. Age will have a different value each time the print age is called, but we'll cover that again when we go to use our function. So we're counting up from 1 to whatever number is passed in, and instead of saying my age, we'll just say the age. The age is, and then this prints out every time, right? So you can see here we're not using any variables that exist outside the scope of this function. And we're also able to print out something from our function, even though we're not returning anything. And that concept of printing out something inside a function, but not actually returning anything, sometimes tricks people up the first couple of times they're using functions. So let's use our function now. So let's say instead of writing our while loop 3 times, we could have some variable here that says Tom's age 20, and then we can say, well, I want to print the age here. Print the age, and when I call it, it's asking for the first argument to be the age, so I'm going to give it Tom's age. There we go. And then I'm going to have another variable, let's call it Alvin's age, 21. I can say print age again, but this time with Alvin's age. And you can see that this makes our code immediately much more readable. So logically, it's logically doing exactly the same thing, but it makes our code much more. We can say we're initializing. Oh, okay, so Tom's age is clearly 20, and then we're going to print out all the ages. That's what we're doing. We don't have to read through, 1, 2, 3, 4, 5 lines of code to figure out what it's doing. And it also allows us to use this bit of code repeatedly, but with different inputs. Okay, let's check that our code works. Okay. There you go. We can see it's doing what we want here. It's counting 1 up through 20, and then again 1 up through 21. So we've managed to do our age function quite nicely. Now, one thing I often get asked is, is there a function too small or too big? Is there a function too big? Yep, there kind of is. We have a pretty good style guide in COMP1511, which you can get through the course website. I believe it says no function should absolutely be no longer than 100 lines. But you should try to keep your functions well under that. It's often sometimes quite useful, for example, to have just one-line functions. Whether that one-line function is just doing this print age is, so that if you had print ages in multiple places, you could change it in one spot and it would always change. So there is no such thing as a function that is kind of too small, at least in my opinion. Again, Alvin and Andrew and Tom, feel free to jump in and disagree with me, but I'm often writing, single line functions.
Small functions good.
Yep.
Is what I would say.
Yeah, I strongly agree with that.
I'm happy to see one-line functions.
Yep.
And it just reads nicer as well. Like, it's really nice if you read through the top level of your program and all you see is just words, and you're like, yeah, I understand what's going on just because it's all words, rather than you could show it to your grandma and your grandma would understand what the function does. That's a good test for if your main function is really nicely done.
Yeah, absolutely. To that point as well, especially when we're marking assignments, like I can't use the mentality of could I understand what this code is doing without ever reading the assignment spec? And usually the answer to that is not essays of comments. It's typically, do your functions explain what they're doing, and that kind of thing. Okay, before I jump into pointers and memory or anything like that, is there any questions or anything like that, or Alvin or any of the others have anything to add to that? Nope. Cool. All right. Well, I will do my quick sort of revision of memory, if you will, which includes some nice diagrams. So let's start another program. Let's just call it. That right? Yep. And I'm going to paste that here just so I can get my. There we go. All right. So we've spoken about functions. What if we had a function that we wanted to use to change the value of a variable, right? So let's say we've got some variable here. My variable equals 1. I'm going to print. My var is, and then print out my number here. And then we want to change the value of my var to 5, and then we want to print it out again. Right. So let's print that again. Obviously, I haven't implemented the function yet. So let's have got that, right? So let's write some function that we want it to just take in the variable and change the value of that variable. So it's not going to return anything because we want it to change the value of the variable. And let's call our function, just something like change to 5, right? And it takes in, the variable. This is not great naming, but the idea is it's called change to 5, and it takes in the variable. Let's call it the variable to change, right? So if we wanted to implement this function, it might look something like, before we learn about pointers, we might say, okay, well, I'm going to pass in my variable. So we're going to call my function change to 5. We're going to pass in my var, say my variable, and we're going to say the variable to change equals 5, and we're going to finish our function like this. So, you can go to your main program. You can do exactly what we were saying a moment ago, where you can read through your program. You say, well, I've got a variable starts at 1. Print out the variable is, you would expect that to be 1. I'm going to change it to 5, and then I'm going to print it out, hoping that it prints out 5. Now my foreshadowing you may be able to predict the outcome of this, but we'll give it a go anyway. Let's see what this looks like. Well, what have I done here? My var. There you go. Evan, I can't believe you didn't pick me up on that.
I'm just laughing at the background. Okay.
Which background are you laughing at? There we go. Oh no, what have I done here?
Printf.
And come on.
When you have been working on Python for the last few days. I get it.
Sorry, you should have seen when I went to Python, I couldn't write print, I only wrote printf. All right, so our program finally compiles just fine. We're going to run and execute it. And you can see, bugger, our function change to 5 didn't actually change the variable. And that is because of a concept that sort of underpins C and some other languages, not that I have vast experience, which is the idea that functions and calling functions pass things by value. So what's actually happening here is when I call change number to 5, it's not passing in my var, it's passing in the value that this variable currently contains, right? So, because we've set my var equals to 1, what's currently happening is we're going change to 5, it passes in 1 as the first argument, so the variable to change becomes equal to the value of 1. And so essentially it's trying to overwrite the value of this variable to 5, but because this is kind of a second copy of my var that just happens to have the original value in the beginning, this is not actually changing the original variable. Now that was a long-winded explanation, but I'm going to draw a nice little diagram here. So I'm going to once again share my screen, but I'll swap to the other way of doing it. Let's share it like this. Hopefully you can all see that now. All right, let's go full screen here. So when we have a regular variable, again, this box analogy is quite a good one. Any variable, as we know, has a name. Any variable, as we know, it has a name. So this is my var. It has a type, right? So this is an int. It has a value, right? So let's have this value in here. What did we say? It was value 1. But the other thing is that every variable that you have in your computer also has an address, right? So let's say this is 0x, which just means hexadecimal, just another counting system. 0xAB, for example. And you say, what's an address? How does that work? The one-liner is that it tells your computer where this box is in your computer, right? And a good analogy for this, and I think it's actually the same analogy that Andrew used in his lecture, is to think of your computer memory like a street, right? So now here comes my drawing skills. So we've got a street like this, you know, here's our center line, and we've got some houses here, just like this. Here are houses, and this is your computer's memory, with each of these houses as a single variable. So, you know, just like a regular house on a street, like you have a house address. So, you know, this might be 0xAB, and in that house, we store the number, we're going to store the number 1. We're going to store the number 1. And houses can only have houses of the same type, the same value inside it, right? That's just kind of how variables work in C, for example. And houses have names, right? We're going to say houses have names now, and this is my var. So one type of variable we can have is obviously this integer here, but because for every value there is an associated address, it becomes useful to be able to store these addresses, access these addresses, and use these addresses. So an integer variable can store a regular number like this, but an int pointer, right? An int pointer or an int star can store the address of another integer, right? So I'll explain that again. So just like any other variable, it has a type, right? Int star, we'll draw it as a box. It's got a name, right? So a pointer is just another type of variable with a name. Let's call it my pointer. And just like any other variable, our pointer also has an address, right? 0x BC, right? So we've just got two variables here, but one of them happens to have this little star here. And what that star means is that instead of storing a regular integer, it stores the address of another integer, right? So inside our other variable, we store the address of our other variable here. So this is actually going to be equal to 0xAB. And the only thing that makes this a pointer, as to say, is the fact that this is the address. This is the address. What color shall I do this in? This is the address of another pointer. And that's where that sort of pointer phrase comes from. So to draw this as, you know, to fill out our analogy here, we've got 0xAB, you know, we've got another variable here, 0xBC, you know, just like any other, it has an address here of, it's got a value of, has a name, my var, and it has a type, where the type itself is int star. The other thing to remember here is that these variables, if I had a double down here, if I had a double and I called it, you know, my double, and I gave it the value, 32.87. It's got an address as well. I could not store this value. I could not store this value 0x1a in this variable, because we've said this is an int star and this is not an int. So we can't store the addresses of anything other than an integer. So here's our memory street. I guess you could say we're taking a little trip down memory lane. That one was bad, I'm so sorry. and we've just got 3 variables where one of them happens to be a pointer. Now, some helpful things about pointers in C is knowing how to sort of manipulate them and how to use them, because it's all very well and good to try and understand them in a diagram, but then how do we use them? So there are kind of 3 key things you need to know with pointers. Confusingly, 2 of them involve the star. So the first thing is the ability to be able to create this, the ability to be able to create our pointer down here. Now, we know how to create our regular variable, int my var. That's relatively straightforward. We say, int, and then we say the name my var equals 1. That's pretty straightforward. But then to create our pointers down here, it can sometimes get a little bit confusing because there's this star and a space involved, but it's the same pattern, int space star, and then the name, my pointer, and then we can just say equals, and then we have to know how to get the value of our variable up here. How do we get the address of my var? And that's where our special ampersand operator comes in. So if you're unfamiliar, ampersand is this symbol here. And if we were to say, my pointer equals, I'm just going to move this across so it's not so confusing. If we were to say, my pointer equals my var, well, in this case, my var would try to evaluate to 1, right? Like we would put 1 in that position, and that's not going to like it because we're putting an integer in something that should be storing the address of an integer. And so instead of getting the value inside my var, we want to actually get the address of my var. And that's where we use our ampersand. And the way I like to think about it is kind of like an operator. So we are taking the ampersand of, my variable. So saying apply ampersand to my variable, and altogether that returns 0xab. And that's how we put our 0xab inside our pointer here. Alvin or others, would you add anything to that?
Look good.
All right. So that's 2 use cases. The first use case we had here, I'm just gonna undo some of this stuff here. The first thing we had here was this is how we create it. This is how we get the address. But then once we've got the address, what's the point of it? Right? What's the point of having a pointer? Wow, I'm really on fire with these today. The reason we might have a pointer is so that we can pass by reference. We can give something a copy of where our variable is, right? We can say, go to 0xab and change something there. Go to this house, right? Go to this house here and change what's inside it from a 1 to a, well, let's use the same example, from a 1 to a 5. So how would we do that? How would we go to, given my pointer, how would we go to it and change the thing that it's pointing to? So this is where the star comes in again, in a slightly confusing manner. So if we have the star without the int bit down here, just the star, and we again sort of apply the star to a variable. So it's going to apply the star to my pointer. Again, the way I like to think about this is an operator, so it's acting on my pointer. What that actually means is go to the address inside my pointer. Oh, you can't quite see that. Let me move that up for you. Oh no, why can't I move this? So that says go to the address inside my pointer. So we remember here that our my pointer evaluates to 0xab, 0xab. So this is saying go to 0xab and set it equal to 5. So we can go to 0xab equals 5. And instead of setting the value of my pointer itself, so instead of setting this value here, what it does is it goes to this value up here and it sets it equal to 5. Sets it equal to 5. So that's kind of our three use cases here. We've got the star, we've got int star to create a pointer. We've got our ampersand here to get the address of a variable, and then we've got our star of a variable, which is called dereferencing. This is our dereferencer to go to the thing a variable is pointing to. Okay, so there was a question here. Will this be posted? Yeah, it will be posted later. Cool. All right, so let's use this knowledge to try to create our function here, which can change the value of an existing variable. So what was happening here last time is we were just passing in the value 1, but what we want to do instead is we want to pass in where this variable is, so that we are able to adjust it, right? So instead of passing in an integer, we want to pass in a pointer to an integer. That's a very subtle change, but it has quite a big shift in meaning. So instead of passing an actual integer, we're passing in where, or the pointer to our actual integer. Okay, so we just need to change our function prototype down here as well. And then we want to get our, let's just put some space here so it can work. Instead of passing in our function itself, we want to pass in where this function is, right? So we can write this up a few ways, but I'm going to do it this way first. We first want to, if we look back at our diagram, we first want to have this variable, right, which is an int star. So that's good. That's what we want. We want some kind of int star. We want some kind of int star to pass in, and this int star needs to store the address of our previous variable. So let's do that. Let's create a variable to pass in int star, because we're creating a pointer. Let's call it again my pointer, and let's set it equal to the address of our original variable, right? So to get the address of my var, we come up here and we say that's equal to the address of my var. So now we've got our pointer variable here, my pointer, which represents the address of my var. And then we want to pass in that address into our change function. So we can just go pass in the address of my pointer. So now inside change to 5, we've got a variable which represents the address of the variable to change. And so if we want to go to the thing that this address represents, this is where we have to use our star operator. Because if we think about how this code is analogous to this diagram over here, my var has an address of, let's just say it's 0xab. So then we can say at this point here, my pointer is equal to 0xab, right? Because we've said it's equal to the address. And because our function passes by value, we're passing in here, we're passing in 0xab. We're not passing in this whole box, we're just passing in the thing inside it, right? So we're just passing in 0xab here. So our variable to change becomes 0xab. And we know from our little diagram down here that when we apply the star to 0xab, it says go to 0xab instead of equal to 5. Okay, so let's put this variable back. And this hopefully does what we want to now. I'll again. Memory, and there we go. We've been able to change my variable to 5 without returning anything. Any questions about that or anything anyone else wants to add in?
I think the point on pointers in general is that if we were to only change one thing, then we could potentially do it without the pointers way and just return that whole value. But with pointers, we then are allowed to change multiple variables at the same time. So if you were to find like the sum of an array and the product of an array all at the same time, then you're allowed to do so using pointers because you can't return two integers directly in C.
Yeah. So the other point that we can make on that is how arrays vary slightly to regular variables. So when we have, let me pull this up here. When we have a function that might manipulate an array, we actually don't run into the same issue, right? So when we had our original problem of change to 5, we couldn't just pass in my var, right? We couldn't do that because it passed a copy of the value in that. But with arrays, it actually works slightly differently. So if we had an integer array, int array of size, let's hash define our size up here, 7 again because we like the number 7, hash define size, let's set it all equal to 0 to begin with, right? And I'm just going to have like the so we'll do the same thing but with a regular variable. We do the same thing we did with a regular variable, we'll do it with an array this time. So we've got an array of size all starting to 0. And in the beginning, let's just put this right up the top. In the beginning, we'll printf index 0 of array was, and then we'll print out the value that represents the first element of the array, array 0. And we're all expecting that to be 0, obviously. So let's compile this, just make sure my code works so far. There we go. Yep. So index 0 of array was 0. But then if I want a function to change the array, someone's alarm's just gone off, change the array, we can just pass in an int array like this of size, pass in an int array like this. And if we write this function, change the array, we can actually do, like, it's a bit weird, right? Because we just tried this with a regular variable and it didn't work. But with an array, we can actually directly change the array to 5. So in the beginning, it's all 0. And then we can call change let's just call this change array. Change array. And we can pass in the array. And then we can print out the array a second time. We'll see what the value is this time. And there you go. So seemingly, quote unquote, without pointers, we've managed to actually use a function to change the variable, like the value of an array, without pointers, as to say. But the thing we kind of, well, I'm not sure if it's been mentioned in lectures actually, is that arrays in themselves are pointers, right? So this variable here called myArray doesn't actually represent the entire 7 blocks of the array. It represents the address of the first element in the array. So to just kind of draw that out a little bit, if I come over here, if I've got my array here, let's say it's 4 elements long, 0, 1, 2, 3, and it's called, Tom's array. That actually represents a pointer to the first element in the array. So to be more precise, the way this might work is that the first element in the array has address 0x01, this has address 0x02, 0x03, and 0x04. And Tom's array in itself, without any extra stuff on top of it, is equal to 0x01, which is why, which sort of inherently points to the first thing. Which is why we can actually call a function on an array, like we can pass an array into a function, and that function can directly access and change the array. Got a question. Can you store an address in a normal int? Yeah, I think other Toms answered that. The short answer is no. And that's to do, I think, again, with the typing of arrays. So when we say, yeah, you need to use a pointer variable. So an int basically isn't big enough to store the size of the address. I think that's the right answer. Tom, you might want to expand on that.
I think that's a reasonable explanation of it. I'm not sure what else I'd want to expand on, unless Andrew wants to expand on something as well.
It's, yeah, Alex, I'll spend a couple of hours on it in COMP1511.
Yeah.
Yeah.
Yeah, there's a rabbit hole here which could be gotten into, but no, that's a decent starting point.
Cool. All right, that's kind of all I had for pointers off the bat. Is there any other questions? Or Alvin, did you have anything else you wanted to talk about?
Nope, I'm good.
Okey-dokey. We could talk about trying to look through some of the other stuff that might be helpful. Maybe I could go over some useful style tips or something like that, which is a little bit more non-technical.
Yeah, that might be a good idea.
Yeah.
That sounds good to me. We're not getting much in the way of specific questions, so if you think that, actually, that's probably a lot on a few students' minds as they're finishing off the assignment.
Okay. All right. Let me pull up my own reference just so. Oh no. That I probably shouldn't have pulled that up. That was SunSwift code, so don't steal it, please. All right. So style tips. Let's just draw these down. So there's a couple of things that we look for when we're marking style. There's a couple of things that are reasonably obvious, like commenting functions, things like that. and there are some other things that are not so obvious. And again, Andrew, Tom, Alvin, feel free to jump in whenever. The first thing I would actually say is header comments, right? This goes back a little bit to what we were saying a little while ago. It's kind of important that the person who's reading your code shouldn't have to have read the assignment spec. And the header comments are a really good place to start, right? So, it's important to have your name in here, a name and a date, just to give it a little bit of timeliness, and just a bit of reference of when it was written. And the other thing that like I look for as a good first indicator of how readable your code is a short description of your program, right? And with the assignment, for example, you can always link back to the assignment spec. You can say more details given here, but just a 1 or 2 liner summary of roughly what your program is doing is a good start. So header comments, name, date, and short description. The other thing we kind of look out for immediately is the use of hash defines. Hash defines. And so basically the sort of rule of thumb here is there should be no magic numbers, right? And what do we mean by magic numbers? There should be no sort of while I is less than 8. Because while that may be technically correct, we're not sure where the 8 comes from. 8 might be size +1, 8 might be size -1, it might be a favorite number. We're just not sure like where that 8 comes from. So to make your code more readable, we want to make sure you have as many hash defines as possible and no sort of random numbers. I'll just make my writing a little bit more clearer there. So that's no magic numbers, and using named and descriptive hash defines where possible. So hash defines is a good one. Commenting is, something you could talk about forever. Is, how much commenting should I have? How descriptive should my comments be? How often should I be commenting? Again, it's another one of those really big topics. But the kind of rule that I sort of use here personally is it should explain what you're doing, not necessarily how you're doing it. And I think that's reasonably applicable, especially for the assignment. So, if you've got a while loop that's maybe 6 or 7 lines or, a bit longer, you should have, just a little comment at the top, just a one-liner that's sort of explaining what this while loop is doing in relations to the assignment as a whole, right? Is it, for example, finding the number of mines in a row? That might be what your while loop is doing. It's not necessarily saying looping through each row and counting the number of mines. That's not a bad comment, but it should more be explaining what you're doing, not how. So comments here. So this should be what, not how. The other thing is, like, how frequently should you have your comments? That again, rule of thumb above, it's sort of above each block of code. If it's not super obvious. And the other thing is if there's any sort of obscure line, if there's any kind of specific formula you're using, if it's size -1 or size, size -1 is pretty common, but if you've for some reason got size +2, that might be a little bit confusing. Why is it +2? It's good that you've used the size, but just give a little comment explaining why it's +2. So any obscure, I'm not going to be able to spell obscure, obscure, Sure. Any obscure lines. So that's commenting. There should also be function header comments. So above each function, you should give, again, a short description. Right, just short description. As you get to longer and longer functions, these will also include what inputs and what outputs. So this is a pretty important one. Above each function, you should have a short description of what that function is doing, and kind of explaining what it's taking in and what it's outputting is kind of the general rule of thumb. Okay, the other thing here is we'll move on with the theme of functions. How many functions should I be using? How long should my functions be? What should my functions be called? All really good questions. And if you're asking those questions, it means you're on the right track because you're probably using functions. And these, we alluded to earlier, should be less than 100 lines. I would, I kind of say to my class, it's like kind of between 40 and 60 lines, in my opinion. I don't know if you'd agree with that, Tom and Alvin as well, and Andrew.
I think for main function. Oh, sorry, Andrew.
I'll go. So ideally, you're looking at something you can see on a single page comfortably. So in a perfect world, it would sort of come down to 10 to 20 lines. But we know often functions doesn't work like that for you, particularly if you're not particularly used to breaking things up into functions. So 40 to 60, yeah, that's okay. But yeah, once it's going over multiple pages, it's making your program unreadable. Alvin, did you want to add to that?
Yeah, I mean, I think you can't really put a number to it, right? Because if you're looping through something, then it's like you need the overhead for the while loop, and maybe there's an if statement in there, so that could be in itself 20 or 30 lines. But I feel like supporting functions should be around 30 to 50, I'd say. But then maybe the main function in itself could be slightly more, just so that because everything is in there, I'd say. But again, I feel like it should be divided based on like the functionality. So like if it does something, rather than specifically, damn, I've got 60 lines and then I should move some of these into functions. But it's more on like, if I could move this and it makes sense because it specifically counts the rows, for instance, then yes, that could in itself could be a function.
Yeah. Yeah,
so there's something I have to recognize is, if you've been coding for 6 weeks, we know that's all this is hard. So while I can say, you can do this break it up into 10 and 20 line functions. No, you can't do this if you're just learning to code. So we expect you to try, but success is, takes years of practice.
Also worth noting that your tutors will give you feedback on this. So they'll show you how to access the feedback for your assignments probably around week 8 or 9, depending on how quickly things get marked. But you'll have personalized comments that explain to you, like here is a thing that you could do differently, here is something you've done well, and so you can take that feedback and it's really useful.
Yeah, absolutely. Okay, cool. Yeah, so the 10 to 20 line thing is a bit extreme. But yeah, as Andrew says, that's something you work on as you get, more experienced, obviously. The only other thing I can think of is placeholder comments. Generally, try to remove. If you've written yourself some to-dos or things like that, maybe try to remove those before submission. That's not mission critical, but it's just a matter of like sort of tidying up your code and things like that.
Also, same for code that you've written and then commented out. it can make it harder to understand your own code if you've got little bits in there that are, commented out 10 lines and you're not sure why it's there or whether it's still important. So I definitely recommend, keeping clean when you're writing your code, not having those little extra bits around if you can help it.
Yeah.
And if I were to add, although this may be sort of a different thing, but I guess with regards to style, even variable naming takes a lot of readability into it. So instead of saying int A, int B, C, D, E, F, which doesn't really mean anything, maybe row num would then be better, because that would then say, oh, it's the row number that we're talking about. So if, in that case, then when we were giving it into a function, or when we were to use that variable name into something, we don't have to think twice about what they are. So I believe, maybe some of you are approaching the assignment on listing the instructions using arrays, maybe, whilst that in itself could be efficient, but I would rather argue, rather than having instructions square bracket 0, instructions 1, instructions 2, instructions 3, I'd prefer, putting in real names such as row num or like length, for instance, because that would increase readability than having those into an array and labeling them as numbers.
It's worth noting. Do you want to take that one?
Well, I was going to give it. There's not so much. Yeah, it's a high level comment, but a lot of experienced coders will tell you the most important thing for readability is choosing your function names well, and the next most is your variable names. And if you get them right, then the actual comments you have to add get a lot easier and smaller. But again, I'd say people, you talk to experienced programmers, and they still struggle with coming up with good names.
I usually put action names because that function does something. So, if the function itself is a bunch of conditions, maybe it checks whether they're outside the minefield or not, maybe. And then that would then be is in minefield would then be a good function name, because it checks whether if it's in a minefield or not, and especially if you put it into an if statement, then you're basically reading English, because if is in minefield, all that variable names, and then you put it in, and then it becomes way more readable than the alternative, which is putting 4 conditions, which I guess makes sense. But what I'm afraid of is, I guess, it's usually I think to myself, will I remember this in 3 months? Will I be able to understand this on like just reading it in 3 months? And if I don't, then I would need to provide more clarification on it.
Yep. I'd also add, just to Alvin's earlier point about using arrays to pass things around, we'll talk about a much better way of doing that next week, I think it is. So like, you may look at what we learn next week and say, oh, well, this would have made a difference to how I would have coded assignment 1. That's totally okay. But for this week, if you are using arrays to pass things around, which just make sure that you've got good documentation around that. I see some people even have like hash defines for what the different parts of the array might be. Now, I should say, when you learn, I think called structs next week, that will kind of be obsolete. But for the moment, it might be a good way of maybe making things more readable, or at least just having good commenting and good variable names to be clear about what those things are doing.
I would say this is probably your whole university career is, I do my next course and I discover, that would have been useful to know in the past. But you can't know everything at once. It's sort of one step at a time.
Yeah, yes, absolutely.
I wanted to say one thing, I guess. Though I first repeat, I can't remember if it was Tom or Alvin said it, was clean out those old comments that no longer apply. The comment that says put your code here, or where you've commented out code, or where you've put a comment in to say come back and work on this tomorrow. Make sure you tidy those up before submission. But the other thing is, don't hesitate to put white space, blank lines inside your program to separate out units So if there's something that should be read in one piece and sort of one chunk like a loop, you might put a blank line after it to separate it from the next loop if your function's got two loops in it. So good use of blank lines, and you can put multiple blank lines between functions and things like that to try and make to separate things out, to give it more readability that way. Oh, and I had one point with hash defines. Yeah, we talked about hash defines is not just a style thing, a readability thing, but if we're doing like a board game where there's a size, and it says hash defined board size 10, the whole goal is if we later decide we want to do it with a 15 by 15 or 20 by 20 size board, we just change one hash define, and everywhere in the program that depends on the board size depends on the hash define, and it all now works. So we can just change in one place, and it may 50 places in our program may change, but then we've got a working program at a different board size. So that sort of hash defines constants. It's an amazingly useful part of programming.
Absolutely. All right. Were there any other topics that we should recap? I'm just trying to think myself as well.
I mean, the thing that I have in my mind would be like scanf return values, which could be useful if you have not started the assignment. Be pretty worried, but then again, that would be a good place to start. But I'm not sure if that's something that we could or should do.
Yeah, we're approaching the end of the stream, but I think that would be a good thing to have a brief segment on, unless, Andrew, you've got something else you wanted to cover.
No, I was going to say I'll talk for a minute or two while one of Tom or Alvin preps to do a scanf example.
Alvin, you good to do that?
Sure.
Right, so
sure.
get yourself sorted out, Alvin. I was going to say, with comments, I don't know, I ducked out to grab a cup of coffee. It's been a long day, but I'm not sure if Tom mentioned this, but yeah, please don't put in comments. The classic one is you see where a student's got a loop and it's got I++ or I equals I plus 1 at the bottom, and there's a comment saying this adds 1 to I, and it not only adds zero value, it's negative. It clutters up the program. I mean, anyone's got any hope of reading a C program knows what the code does. So the comment has to tell you something useful, something extra.
One mantra that I like to use, which is somewhat helpful but useful as you go through your career, is comments don't compile. So if you have a comment that says something and then you go through and change a little bit of code, and the comment now does something different to what the code says, you've actually hurt yourself, because now you've got the comment and the code, and you'll read the comment and think, oh, I understand what's going on here, but the code does something different. Which is why applying comments to something that explaining what you're doing rather than like exactly how you're doing it is useful, or having comments that are like apply to a large enough bit of code that they're not just saying this is what this one line does, they're saying this is what this little block of code or this function does, is just so much more useful than just talking about adds 1 to I, or those sorts of things.
The other comment that makes me sad is if you see a comment that says variable I holds the row number. You're thinking, then maybe you should have called it row number. All right, I think we're handing over to Alvin to talk scanf.
Yep.
Cool. Let me just share my screen. Hopefully everyone could see my screen now. Yeah, so I guess I'll just start from sort of scratch when I sort of talk about scanf return values. Probably worth it to put it there. But when I usually talk about scanf values, I usually start with, because I think that's also the week where we introduce functions. But notice that scan in itself is a function, right? Someone made this before, and it's currently in this standard input-output library. So then we just know how to use it, but technically, do we really know how to use it? And that's because, yes, so far, I guess, on week 4 at this moment in time, maybe, you just use scanf in the way that, you ask the user for a number, and then they would sort of give you the number. Please enter an integer, right? And then you do enter the integer. And this is sort of something that you can use all the time in CSC computers, is that if you want to know the definition of a particular function, then you can just simply type in scanf. This is useful when we used to have exams in person, whereas now I guess you can Google on your exam. So I'm not sure the exam conditions allows you to do that, but that's a different point.
Yes, you can Google.
Okay.
Should be.
Cool. So as you can see here, when we learn about functions as well, we know that this part here is the return value, and you can see how this actually returns an integer, which is like, oh, what? I don't really know. And because at this point, we just told you to just scan stuff in without actually returning things in, right? So if we want to sort of know what the scanf value does, we could then simply catch the return value and see what happens, right? So if we were to do something like int return value, so we're catching what the scanf function does, we can test out what it actually does. Is %d. So here, do you see how I make this variable name return value so that I know that variable itself is the return value? So variable names are very, very, very important into like understanding what you just built. So here, I'd say scanf return values, scanf return values.c. Hopefully it compiles. It does, and it just asked us to enter an integer, right? So if I enter something like 42, the return value is 1. But as computer scientists, we want to break things sometimes and see, what happens if we enter something else that's not a number. So maybe I were to enter Alvin, then you can see how the return value is then 0. And then I guess, in your labs, you're told to do Control-D. And at that moment, we can see how this return value is then -1. So you can see how there are 3 different outputs that we are seeing right now as to what the return value of scanf is, which is sort of important, but we don't really know the whole information, right? Because now we're only scanning in one number, and probably, we can kind of guess, oh, maybe this is the number that you successfully can scan, or maybe every success scan just gives you 1. We don't really know. So if we were to try this out into 2 integers, so you're scanning 2 integers at the same time. I mean, you can't, the safest way is to actually read the whole documentation, I'd say. But then again, I feel like this sort of demonstration helps you understand what's happening. So here, if I were to catch the return value of scanning in 2 numbers at the same time, and I'm just going to print the same thing as well. Let's see their behavior, right? Probably I should mention, please enter 2 integers. Grammar. And now you're asked 2 integers. So I'd say, maybe 1042. Look, return value is 2. Maybe Control-D. -1, unsurprising. So whenever you press Control-D, it gives you -1. But then I want to be, tricky and do something like that. Or maybe, I don't know, Alvin 10. Or, I don't know, my full name. And it gives me 0. So you can see how these are all the informations we know about scanf. So when we scan two numbers at the same time, it seems like when they're both successful, it's 2. But then if one of them is successful, so like 10 Alvin or like Alvin 10, so one of them is an integer, in fact, and clearly Alvin isn't, because Alvin isn't an integer. And I think we have learned about strings and characters so far, but it'll be in your tutorial on week 7 too. But you can see how this gives you 1, but this gives you 0, which then in turn sort of, you can kind of guess like, oh, maybe if they found a wrong value that the user gave, they directly stop caring about the second element, right? So that's why this return value is 0 and this return value is 1. And obviously, if you were to write 2 strings rather than integers, then it would then be 0. So what could be useful from these facts that we've known is that essentially, if you were to summarize what you've done here or what I've done here, then scanf returns the number of integers it successfully scans in, with the caveat of like, if you do something like this, then it stops directly when it's not an integer. But what can we do with this flag, right? So if we were to keep scanning all the numbers again and again and again, then we can sort of, like, I guess, a type of scanning in integers until a certain point would then be like, when you're scanning in the mines at the start of your assignment. But what if I want to scan in continuously until the user decides to stop, right? So, another way to think about this and to use the scanf value is also that, if we were to go back to the single number version, we can essentially sort of know, because we know what the return value is, we know when it's successfully scanned in. So, rather than, printing the return value because we just wanted to know the behavior of the return value, I could actually just say if return value equals 1, because of the number of integers it successfully scans in, this looks like it could be something you can define maybe, but even then, probably shouldn't do that for this particular example. So we know that this means that num is successfully scanned in. So again, this isn't too clear sometimes if you don't know the exact behavior of scanf, and hence I put this comment in. So num is successfully scanned in. Num, or I guess I could sort of write it in the comments as well. Num is %d. So I could just print num, and then here I could put else, which is then I guess wasn't given an integer. New line should go over there. So if we were to find this out, scanned in again, you can see how if I were to say 42, num is successfully scanned in, num is 42, but if I were to say, I don't know, Alvin, then wasn't given an integer. So this is useful, right? Because we know when the fact that we successfully scan in something and when we don't. So if I were to pivot back and say, what if we want to continually scan in until we can't scan in anymore, then it seems like it's a similar format, but instead of just doing this once, which is what an if statement does, what we instead do is that whilst num is successfully scanned in, so we can sort of change this into a while because we want to keep going until it stops scanning in. Then what we can do is, num is successfully scanned in, num in something, and then we can rescan again, right? So I'm just gonna put this as a chunk and put that as well as a chunk, maybe. And what this allows you, right? This could be a previous, you can run this, see what happens. Again, when you get an error, don't be afraid. Just look at the first error, because sometimes, like, this is short error, but sometimes this error, some errors could be compounded. So always look at the most top error and see what the line number is, which is this is 18. So you can see how shadows a local variable. So it kind of means that we have defined return value before. So then we could just put this again. Technically, that was allowed, and that's why it's a warning. But again, it would be bad style, because even, like, why would you have the same name if you keep redefining variable names? And then again, if we press VCC and try to run this, then if I were to say 42, you can see how it asked me to scan in again. Let me try to have this side by side. Right. Probably make the terminal smaller. There you go. So what happens is we're now in a while. The very first time it asks please enter integer, it'll be line 11, right? And then it scans in that num. And then if the return value is 1, which meant that if num is successfully scanned in, you print the num that you just say. And then here, this please enter an integer again comes from this line 17. And then so if I keep going with this integers, right, it keeps asking me to scan in again, because all the way, as long as you successfully scans in an integer, which would mean that return value is then 1, you would keep going, and it would ask you again and again until you do something like Alvin, and then it stops. Because the moment you said Alvin, or I guess Control D, what happens is then scanf, again, as our experiment showed earlier, the return value would then be 0, and if you press Control D, the return value would then be -1. And because it's 0 and -1, it then checks again. It tries to check whether the condition is still true, but then it's not, because 0 or -1 isn't 1. And at that point, it exits the while loop, and then we'll go to line 20, and it will end the program. Again, if there are any questions, please ask me. But I thought this is sort of a good way to show return value of scanf. And what's important about this with the assignment is that, yes, for the very first part, you're just scanning in the mines. But for the second part, when you're supposed to write the instructions or to record the instructions that the user gives, the overall structure would then be something like this. Because, return value means that you've successfully scanned in something. So it would be like the very first command. And then, you do something with the minefield array inside the commands here. But in overall, the structure would then be something like this. And if I could point out, this also seems like a typical while loop array, because yes, it's not int I or int counter equals 0 here, but you can see how this could be like that, a similar version. And then this is sort of like your I++, which meant that it keeps going. Well, I guess it updates the state of the while loop, whether I would then break the condition, or I guess where return value would then break the condition. But I guess the main difference is that this could go on forever, whereas with the I and increment their thing, it would stop one day. So are there anything that you guys want to add, Andrew and Tom's?
One thing I wanted to add is that warning wasn't just a style thing. Actually, it had picked up a weird, what would be a bug, and a very hard to find bug in your code. So
Okay.
you treat warnings seriously. We could leave it as an exercise to figure out what the bug is there, but it would actually break your code. So always fix warnings. That was a great example, Alvin. So I think we're out of time. There's nothing in the chat. So I think we're probably wrapping up here. So huge thank you both to Alvin and Tom Killingback for a walk through key topics for revision in COMP1511. Unless Tom number one has something he wants to add.
I feel like
It
we
may
need to
be-
revise this Tom number 1, Tom number 2 thing. It imposes an ordering. I propose like Tom A and Tom 1, but we'll have to figure that out later.
So I've already
Or we can
penciled
go
in
with the-
for next
Sorry.
term. I'm only hiring one tutor of any name, one Alvin, one Tom, and so on.
I think we'll have to have a conversation about that afterwards then. That's a bit concerning. We could go with the sort of like WHO version of naming. So I'll be like Tom Alpha, and you could be... Anyway, yes, I think that's pretty much. There's one very quick question there, which is: should the border of gameplay minefield be dependent on size? Did we answer that? We have.
I don't think so, not yet.
Oh, okay. So the answer I would give is it would be best if it was hard coded, but I don't think as part of the assessment that we're going to be changing the size hash define. So what I would recommend is if you've got time, try and make it good. Your tutor will probably comment on it in terms of style, but you won't have to deal with it in terms of the marked assessment part where we sort of test your performance.
So to
I
repeat
would
what
feel
Tom
like-
said there, we won't change the hash define for size and test your program with that. But but in a later course, we'd definitely do that.
Yeah, we've often thought about doing it, but we haven't this time. Cool. All right. Thank you very much for coming. We'll post this to the YouTube so everyone can watch it afterwards. I'll probably include a link to it in the announcement that we put out this weekend. But otherwise, good luck for assignment 1, everyone. And I think that's where we'll end the stream.
Good luck. Stay safe. You can't get COVID working inside on assignment 1. Hopefully. All right. Bye, everyone. See you Tuesday.
Thank you.
Thanks.